This video is about differentiating exponential functions. We're going to be looking at functions that have this type of appearance, f of x equals e to the x. So we're specifically going to have e as our base, and there's going to be a variable in our exponent. If we look up page 25 in the log tables, we'll see that the derivative of e to the x is just e to the x. And this makes it look like there's only one step in differentiating an exponential function, but actually it's really important to bear in mind that if the exponent is anything more than just x, we're going to have an extra step. So we need to be careful. If the exponent is anything other than x, we must multiply by the derivative of the exponent. So let's have a look at an example to illustrate this. So here's our first example, y equals e to the power of x squared. We want to find dy dx. Okay, so the rule in the log table says that when we differentiate an exponential function, we end up with exactly what we started with, and that is the first bit of our differentiation of this particular question, in that ex squared is going to get written down again. So I keep that as is, but then I must take my exponent, I must differentiate it and multiply the result on the end. So I'm multiplying in this case by 2x. If you want to tidy this up a little bit, all you have to do is just put the 2x in before the e to the power, as we tend to put exponential terms at the end of a term. And that's dy dx found for e to the power of x squared. Here's a second example. This time we've got y equals 3 times e to the power of 2x plus 4, and I want to find dy dx. Okay, so I'm going to write down the 3, which is the coefficient on the start, then the e to the power is going to get written down as is, and then I need to multiply this by the derivative of the exponent. So in this case, I'm differentiating the 2x plus 4, and I'm going to get 2. And then I'll just do a little bit of tidying up, and that's just going to entail multiplying my coefficient of 3 out the front by whatever I got here at the end. So in this case, my derivative is 6 times e to the power of 2x plus 4. Job done. Here's a slightly longer example. So I've got y equals 4 times e to the power of 2x plus 1 squared. And I want to find dy dx. Now, I know that I've got exponential differentiation going on here because I've got an exponential term, but if you look in the exponent, you can also see, hopefully, that there is another type of differentiation that will be involved in this particular question, which is the chain rule. So when I go to differentiate the exponent in a moment, I'll have to keep the chain rule in mind. If you're confident in how the chain rule works, at this stage, pause the video and give this question a shot, and then play and see if you end up with the same solution as I do. Okay, so the 4 is going to stay put. That's my coefficient. I'm going to write down my exponential term exactly as I saw it. So to start off with, there's no change to it. And then I'm going to multiply by what I get when I differentiate that exponent. So I'm differentiating 2x plus 1 to the power of 2 now. So how do I do that? Well, okay, I'm going to bring 2 down in front and multiply it by the bracket 2x plus 1. I'm going to reduce the power by 1. Now you can put a little 1 in there if you like to indicate that, but because it's a 1 there isn't strictly a need to do that. And there's one more bit. What is it? It's that I must differentiate also what was inside in the bracket. And I multiply that on the end, and that's a 2 again. I'd like to tidy this up slightly, and I'll do that by multiplying my numbers together, 4, 2 and 2, which is going to give me 16. Next I'll stick in the bracket for 2x plus 1, and lastly I'll have my exponential component of the term. And I'm done.